Hi everyone, I'm Esther Trilsch from SideFX, and I want to show you today a few more information about how to actually set characters up with the new Apex workflow, and I in general want to give you a few more technical goodies and what it means to work with Apex. And in the beginning, I'm going to iterate about a few points that some of you might have already heard in the launch, but they're very essential for everything that we're doing with Apex. So no worries, there's going to be a bit of iteration, but I'm jumping into the details right after that. So what we know from what we already might have learned is that what we're doing now with Apex in comparison to KineFX is we started with KineFX bringing the skeleton into geometry. And now with Apex, we're bringing everything that is relevant for our animation to be working in the viewport, to be animated and played back. We're bringing all these data in a completely data-driven approach into geometry. And one of the reasons for that is that it allows us to be much less dependent on heavy HDA networks, which makes the life for an animator a lot easier and also opens up a lot of procedural power purely for character setup work. And everything driving it underneath is called Apex. So now that we have all these data in geometry, we need to have an easy way of organizing them. So we are using packed geometry folders in order to do so. So we're going to just start fresh and nice and easy with one character. So our one character is usually needing some inputs. So we're going to have a rest geometry. We want to deform that. Usually we use a skeleton that gets some transformation data, and then our character can move around. Everything driving it is our rig. The rig is an Apex graph. And that graph usually determines what kind of inputs you get from the animator, what kind of parameters they have, what kind of logics they have. Do they have IK? Do they have FK? And so on and so forth. And we pack all of this nice and neatly together to our geometry. One thing that you can see here is that the names of our geometry actually have extensions, similar to file extensions that you might be familiar with. And we can use that for the viewport, for example, to associate certain file types with certain behaviors. For example, I have a rig, and the viewport knows what a rig is and can fetch certain, for example, the input, rest geometry, and so on and so forth from these extensions. So bear that in mind that we don't just have files and folders, we also have file extensions that you're also familiar with from any other file and folder structure. And the nice thing about our geometry picture is this is the most simple case what a character could be. It's literally just one geometry. It's that simple and nice and neat. So now we're coming to our animation scene where we have a lot more data to handle with. So we might have one or multiple characters, and that's the beauty of it. We are now in geometry. We can add as many characters as we want to our one data stream. But the most important thing is we do, of course, also want to add animation to it. And animations are in the end nothing but curves in 2D space. We know that we can store subcurves, like usually as geometry, and we're now translating that over to these called channel primitives into geometry as well, that we can store along, interactively modify with our animation editor, with setting keys and all these things that we do in the viewport and in our UIs. They're actually changing these animation curves that we are creating. And of course, we're also going to have other data that the animator wants to create in the viewport, such as ad hoc constraints, locators. You already saw the dynamic notion tool. All these things can be stored and modified along on our scene. So we can boil it down to the very simple animation network, which means our animator can focus on the scene animator node. So the lowest node in the network picture, that's where our animator lives. That's where he's happy. And that's what allows us to have that viewport-centric workflow. So what's driving it underneath? This beautiful, hopefully not always that graph, but, but what's driving it underneath is Apex. And with Apex, we gain a few huge advantages when it comes to evaluation. We already know now that the Apex graph can be stored as geometry. And that means, first of all, that we can have the full power of proceduralism at our hand to modify that geometry either through SOPs or through Python, aka the viewport. So we're fairly flexible on where we're changing it and when we're changing it. Next principle that we can reduce from that is we're just storing the graph along. We're not getting any inputs or outputs out of it. It's just a graph. So when we actually want to fetch something, we can decide what we're going to fetch and when we're going to fetch. That is also, by the way, it's called delayed evaluation, and we're going to combine it with partial evaluation. That means We just evaluate what we actually need. And that means that everything in the viewport is going to be nice and fast, and that's what we want in order to have a good animation workflow. Another concept, and by the way, that HUD is dynamic. It's being recreated as we're playing, and I'm just going to play it again because I can. We have the concept of it being of a graph being self-healing. That means you can actually change that graph at any time, and you can tailor it to the current needs that you have either in the viewport or on sub level. It's been compiled on the fly, which keeps everything nice and fast. So everything we're doing here is designed for live real-time proceduralism and very much tailored for viewport workflows. Do something. And here we go. So now we know that we have, of course, also the concept that we determine what we evaluate when. Here we evaluate our scene in the viewport for the animator, but what we're actually storing along is the scene. Now we look at the graph that's actually driving this animation, and we can see here that it's in fact really points. So when we are now in the graph UI, where you usually do your changes, you can see that the geometry in the viewport is actually updating as I'm doing it. The graph is a combination of numerical, custom type, and geometry operations. And in this case, I'm just creating a few verbs, and I'm going to turn Electra into Taurus Lady. So all subverbs are available here, plus the given extension that I mentioned. For the C++ lovers, it's a custom open custom type system, so you can actually even extend it. Now we go back to our animation. We see that the updates are live. They're directly there. You can see I just changed the whole geometry. The time dependency is just introduced at the very last point. This is essential. Your scene is going to be much slicker and faster if you do so. So we're just fetching, again, even from that scene invoke node, just the bit that we need, just at the very end. So everything is intended to be kept lightweight. And because it is such an important point, I'm also going to show you this concept of the graph dynamically changing again. So this is the locator tool, and you can see these changes. It's actually creating a little control hierarchy in the viewport every time you're actually adding one of these locators, or it's removing it. And that's what I mean. It's like the graph is tailored to your current needs. If you don't need a control anymore, it's simply going to be kicked out of the graph. And that's how easily you can update these graphs using either Python, that's what we're doing via the viewport, or using subs and graph operations in order to get there. So now we know that we can modify our graph, of course, with the graph UI, you just saw that. But when we want to set up a whole rig, you definitely don't just want to do that manually, purely in the graph UI. You want to have procedural tools. We all want to work with maximum reuse. So we also looked into that for you guys. But before I go into those details, there's a few essentials to point out that might be a tripping stone. So this is the most simple rig I can build for you guys. This is Flippy being attached to a control. And what you can see is the purple node is our transform object. That's the bread and butter for a rigger, so to say. So you can define with a transform object. It's similar maybe to a null, an object level. You can define transformation hierarchies. You can define rest position. You can do all these numerical matrix operations that we usually do in order to achieve these typical like acyclic transformations that we know from rigging and animation. We can plug them, and what we can do is we can use skeletons in order to create these transform objects. They are not the same though. So we can use a skeleton in order to know what the rest positions for these elements are, and in the end we can transform a skeleton, which is just geometry, right? We can transform that with those matrices. It's not the same. They are two different things, and they don't even need to align in their hierarchy. Very important. Skeleton and graph are two different entities. And the skeleton for our rig logic is just a geometry input. And the red bits here, by the way, that's Flippy. That's where you can actually see how Flippy is being transformed with the X-form information from that control. So now, rig components. Of course, we want to work procedural and modular. Maximum rig use is very important for us. And it is also very important that we are creating a structure that is maximum flexible. You saw this already with everything that we are showing here. We don't just want to be purely dependent on HDAs. So what we're using for the rig component workflow is we're using SOPs as an interface. The actual functionality is not in SOPs directly. So that is also a very important difference, because why? What can we do if we have something that's not just in SOPs? We might as well also in the future want to use it for the viewport. Another very important point is we all know that every rigger has a different idea, and every animator especially a different idea, what the perfect rig is. So it's highly important to us that it's possible that you guys can customize this. You will all have it and you can fill it with your own components, your own tools, and grow it into your rigging structure. So we're providing very much a framework. So, and also one note to bear in mind, because that's something where we are heading for the future. The rigging structure is not just built with the traditional rig picture where we have one giant rig graph with lots of functionality. This is completely supported, as you could see. But we are also having maybe a different mindset there that is more open to ephemeral rigging, which means we're going to have smaller tools that the animator applies while they are in their viewport, and that means rig decomposition. But that's a bit more beyond 20, but keep that in mind. There's more stuff to come. So now let's see that in action. So here you can see my skeleton and my geometry input, and I'm now creating one of these rig components. With the drop-down menu, I'm getting parameters created for me. It's actually just 2 or 3 different HDAs that we're having, and the parameter interface is a bit of a shapeshifter. All of those functions are pretty much applying a function to the overall character. And you can see how your rig dynamically changes, how you have parameters to change it, and how it actually updates in the viewport. That's what I mean with SOP is a really good interface actually for rigging, because you can control your parameters, you can look at the graph, but you can also look at the actual output in the interface. And everything reacts instantly. This is not speed up, this is the actual interaction. So you can see here, I turn mirroring off, no control anymore there. You can also see that the graph is updating. I turn it on again, you can see the graph is changing. Mirroring is there again. And last but not least, we are also able to configure metadata on our graph. We are using them, for example, for our control shapes. And these are being stored as dictionaries and properties or as tags. This is essential when you work with rigs and you want to modify data and fetch and filter elements with that. And that pretty much brings me also to my next video. Oh yeah, and of course you can also modify it with SOPs, with any kind of SOP operations that you have, which is wonderful. So now you see no IK anymore. And play. So now, of course, we want to see that we can also transfer these data over. And for that, we are now using our tag and property filtering system in order to flexibly bring our very simple character Electra over to our more complex base rig from the luchador. And as you could already see, the base animation works. We can test our rig right away, and we know we have set something up where the functionality is there. Now I have the different rig, much higher joint or node count, and you can see here the functionality is still being transferred even if now my controls might have completely different orientations. It's being dynamically picked up because I have these generic component blocks. The animation is broken, so I have retargeting in order to fix that up. I'm not going to jump to that there, because you guys might have a lot of questions on how on earth does this component even work. And for that, we're going to come to a bit more into that. So we already saw now we have these daisy-chained nodes. It's always the same node. And you might have noticed there's a second input. And you can actually use that from the dropdown. Here I have an example where you actually see exactly that second input. We're using it in order to create these locators that Warren uses for pivot points. And now you see that we're actually feeding a graph in. And that graph fetches the whole character, aka the rig and all its inputs. You can fetch the rig from it specifically. You can modify that rig with nodes, and you just update it and pipe the whole character out again. So we have actually a bit of like visual coding style with nodes that allow us to modify any given input to your character. And we are, by the way, also relying again, and you can see here this parameter, this locator's parameters, that's actually what you're seeing on your SOP node. So SOP is in a way our nice interface in order to control and maintain a graph. And what you can see here is that I'm, by the way, again, using tags in order to fetch certain data based from my skeleton. And just to iterate over that concept again, we can see here a very simple rig invert foot setup. and when we go to the graph again, you can see here, those are our input parameters. And these parameters that we have on the node are exactly that. So the subnode is just there so that you can easily configure it, test it, tailor your rig changes exactly to what you need for your function that operates on your character. So this is there in order to sum it up. It's pretty easy actually in order to set it up. All you need to have for your rig modifier graph is character in, you do something with that, character out. Why is it the whole character and not just one specific rig? If you think about what you can do with rigs, you have actually a multitude of options. It's usually not just the rig that you might want to change. Maybe you want to change your skeleton. Maybe you want to add a blend shape. Maybe you want to kick a blend shape out. You can do all of that. You have the whole character plus its inputs available in order to change and modify that as you go. And we have a very generic format that always works. Like always, character plus a bunch of parameters in, updated character out. And in between, you're fairly free to do whatever you want. So how would I create one of those? There's a few points and a few that will make your life a lot easier. And so I'm going to run quickly through one of the processes, how I would usually approach it, for example. So in my case, I want to create a super simple twist setup. And I'm starting just with an FK, not twisting, not great. So I'm creating myself here a little example, and you can see I actually just modified that graph right away. So I just put that in order to test what I actually want. That's the typical prototyping thing. You just have a small example, you test the functionality, and then you continue. But what I already did is I created myself subnets in this graph. So you can have in the graph UI, you can have subnets that you might know from any other from subs. So we can do the same here. So I'm already organizing it because I want to make reuse now out of it. Because twists are of course great, but usually you don't know how many twist giants you might gonna end up having. So we want to have a flexible setup. So creating a generic solution for that is much better than always just copying something into your rig. So now that we continue, you can see when we dive into the subnets, that's really just a few numerical operations. I'm really just grabbing the twist float value. There's no magic happening there. But I can bundle it up nicely in order to get there. So one cool thing that we can see there with these two red nodes is, wouldn't it be cool if we can store them like an HDA? That would save so much work. I don't need to create 7 nodes all of the time. I can just drop this new one. And yes, you can do this, and we call this concept subgraphs. And you can actually just store them to disk, load them again, and you can use them like any other HDA. And I can just highly recommend working with that in your pipelines because it will save a lot of work. Whoops. Let me jump back. And let me jump to that point. And here we are. So now you can, what I'm doing actually is I'm isolating these two subnets that I'm having. I'm just packing them into a pack folder, give them a name for my little, Apex HDA, aka subgraph. Then I'm just storing it to disk, and you can see I can just drop it down like any other node, and it just has exactly the name that I gave it to it. That's great. So when we now actually want to bring that setup in, all we actually need to do is we just need to add these nodes, and we need to connect them up, right? And that's all we're doing with the component script. We have now a flexible input to test everything. And the first thing that we're starting with is that we're actually just creating these pink nodes, aka we fetch the rig, re-update the rig. If we now look at our lower part there, in the lower graph, you can see, well, nothing has changed because why? We haven't really done anything. What we are doing now in the next step is we're creating these green nodes. So let's see what we're doing here. Look at our parameter inputs. We actually have now parameter inputs to enter in order to fetch the start and the end. And what I very quickly did in this video is I pressed that little update button there, and that creates these parameters on the subnode for me. So now I can actually set up my test inputs in order to get the start, the end, and the middle part of my little twist setup. Now that we have that, we can continue. And next thing we do is we actually add the nodes, and see, it's literally operations like graph add node, and it adds the node with the given name and the given functionality. Now we're setting up a few parameters, and the rest of these operations are pretty much just operations in order to connect these elements up. And one very important point is that dark bluish turquoise set of nodes is a loop. We actually support loops and conditional structures in Apex. They're great. And they're really great if you have graphs that modify these other graphs, like our component scripts. Don't put them in the rig themselves. You're going to kill your performance, and you will be happy for a very small second because you have a dynamic rig, and you're going to be very unhappy because the rig is going to be dog slow. And the reason for that is simply that it's intrinsic to the natures of how loops are being built. Remember, we are having the profit of working with partial evaluation, so we just evaluate what we need. If we throw all our data constantly into loops, we cannot really do that anymore. So in order to keep your rigs very lightweight, rather regard them as a result and put the heavy structures, such as loops, rather into your components. They can tolerate that a lot better than the actual rig that the animator interacts with the whole time. So this might be a very essential tip. So, and now that we have this, we're gonna connect in our little twist inverter. Again, we are actually just operating with like connect operations. In the end, we just promote our rotation out. And now we're just packing it into subnet so it's nice and readable. And we can test our functionality. So now we just reproduced our prototype exactly with that. Now we changed the joint number in order to see if our prototype is still holding up. And yay, I have a modular twist component. Isn't that great? And again, why are we doing this in graphs? Again, what can we do with graphs in the future? We can bring them to the viewport, so don't forget that. Let me go to the next slide. And in order to prove my point that the system is actually scaling up, I already mentioned that the chicken's being set up exactly in that way. And you can see that we can see how the rig is kind of following this evolution. So we're starting with a very simple FK setup. We add more functionality. We can see how our graph changes, and we can see how the functionality changes. And what we're getting out of this is a very nice and neat vertical layout that can be very well organized in the sub picture of the rig so that you have the maximum read there as well. And in the end, of course, you can see how much the graph has grown, how complex it has become, because we have, of course, so much functionality in there, which is great, and we can all execute it for the animator. And in the end, we see the final controls there. And I'm going to skip the one. And another goodie that I have for you is now we saw these typical controls that you know, all with a handle. This one is a different one. That's an abstract control. What you can do with that is you can control float values, such as, for example, blend shapes. And you can just drag around in the viewport in order to get these like combo shape interaction styles. You can also use the channel widgets for them. And you can also very easily set them up in your rig. So that might be a nice convenience in order to interact with that. And so if we, but now we're going to pushing it one step further. This is a bit more experimental, but it might also going to show you a bit of power of what we can do if we put everything into graphs. We're also going to have the rig script, and what it allows you is to work with your rigs and templates. So instead of focusing on the rig as an output, we rather focusing on the, well, let's call it recipe on how you actually got to your rig. And we can store that, and we can use that either for creating bigger tools out of smaller tools, or we can simply really use it as a fully rig template that you can apply to various other characters. And when we look at it, you can see the advantages here in the scene. So here you see it looks very similar to start with to the normal auto rig component node. But now the graph that we are seeing is actually not the rig graph, but that's the rig script graph, aka our template that builds up node by node. And what it actually stores is exactly that component that is being executed, plus all the parameters that you configured. So you can see it's a mirror to what we have here. So it is very much a, so the vertical picture that you have from your SOPs is a mirror of the horizontal picture that you get in your graph. So you can store everything that you did in SOPs and that is connected to the red line now in one graph, and you can execute it in one go. So when we now look at the graph, this here is now, in the end, building the whole rig. That's great. Now we take that red output, where we know that the whole template is, and we just use it as any other component. And you can see it builds the whole rig in one go. Just one node needed. Great. And that is, of course, cool for templates, but I can still even configure that thing with parameters. So you can see I have a whole rig, and I just turned mirroring on or off. So for that, we even provide more functionalities. And you can see in a second how we actually set this up. So now I go to my IK arm. You can see I have a mirror attribute. And what I can do is I can go to promote parameters, and I can actually promote that parameter. And you can see that it's doing exactly that in the graph. And everything starts to look a lot more like one of these rig components again. And what we're doing is pretty much we're just creating a bigger component out of all these smaller components. So that's, of course, great. But now I already said we can transfer it to other characters. We have the luchador here. And you can see I can now easily also transfer the complete template over, and I can configure it exactly in the same fashion that I just did. So that should facilitate any kind of template workflows. And if we think in the viewport about animators applying elements just with a button click in the viewport, that might be one of these things that facilitates exactly that, because you can execute and apply a rig just with a button click. Nope. So just to iterate this, our rig script components is actually nothing but a bigger component script, just with lots of little baby component scripts inside it. So now we talked a lot about graphs, modifying graphs. Of course, we also have a Python API. We know a lot of riggers are familiar with that, and it also comes with a lot of advantages. So that is always an option. And it is something that is also very much combinable. So here we have an example from Magnus Möller, and he actually built in a very short time this little auto rigger modifying these graphs with Python, and in order to set these two little cuties up. And you can see that we have two different characters. Wonderful. And we can see we have the full functionality of IK and FK here to our disposal, completely set up here. And the cool thing about it being built in Python is, of course, it's easy to set up, has the advantages of creating loop structures very easily in Python. One thing to bear in mind, though, this setup is very much HDA bound, because we have different Python steps. That means we are now bound to HDAs. For everything that I mentioned with the viewport, of working more viewport heavy as a rigger, that is a little bit more complicated when it comes to Python. The graph is very well maintained. Python, not necessarily, because you can do anything in here. And he's also making here, in this case, one very good example of the use case of tags. So here, tags are being used to define the various functionalities, and we're using tags and loop structures in order to create elements like IK exactly on the defined limbs that are being tagged with the given tag. And that concept applies to Python, it also applies to the graph, and it is incredibly powerful working with these tags. Anything that you hook together, like Lego blocks and these components, is something where you can make use of tags in order to be name independent. And if we talk about various tag inputs, that's how you do it. And here, of course, you can see, again, how our graph is being assembled using Python, and how we can use the Python API and desegment it using Python SOPs for that. I already mentioned that tags are essential, and here you can see it again. I have my two graphs using these tags, and what we are doing is we are providing actually a completely new filter syntax for our graphs, and that filter syntax can be seen down below here, and it's relying on the same syntax that you might be familiar from Solaris. And that allows us to filter after tags. As I already mentioned, you can use tags as you know it from any other applications. It's just a string array, and you can assign certain names to certain elements. You can transfer them from skeletons over to your transform objects for filtering, which is incredibly handy. You can also filter, for example, after node type and all these kinds of things. We also have properties available. Properties is a custom metadata type, so you could store, for example, the information like my limb name is leg, and you can filter after that, and you can filter after the keyword as well. So think about that when you set up your structures for maximum reusability and maximum flexibility. And last but not least, I'm going to show you again how Apex and KineFX can work lovely together with our wonderful chicken. And I'm going to say a few more details while I'm going to show you this. So when we come now we have our rig setups and we want to work dynamically more as a tech animator. We have now the option that we can animate directly in Apex. And we've already seen that. What we can do now is we can actually convert our rigs back to a skeleton by extracting controls based on their path. And we can be very selective here. Now I'm actually really grabbing again a motion clip, a mocap clip, and I can transfer my data over using the rig copy transform nodes in order to do so. It is very important to point out here that the purple node that you're seeing, aka the one in the upper one, needs a twin, and that's the control update params node. So first you fetch your control, then you're modifying it in KineFX land, and then you need to update that in order to work. And that's how we can then track back to our according proper character. So a very important point to make. And when we pipe these information into the scene invoke, we can directly use it. We can directly get our scene being updated by that, but usually we want to update our channel primitives. For this, we always need to create a motion clip, and we have the channel primitive from motion clip node in order to update it accordingly. Both nodes are necessary. Again, we're working now with dense data, so what we can do is we can reduce the sample rate, and now we can hand animate on top of our given mocap animation in order to have a fluent workflow. So now we just created the first loop. Here, this is actually a full Apex animation, and you can see I can even splice that up and just isolate the chicken and work with that. In this case, I'm also just isolating one joint instead of the whole skeleton that I'm filtering out, and now I'm applying my KineFX changes here. I have my curve, I resample the curve for better distribution, and I have a very simple transform path VOP in order to modify the joint position. Again, you can see this twin node and then the motion path, essential in order to update our channel primitives. Now we are fetching with the pink node the existing channel primitives, update them, and just then is it possible that our chicken will follow along. And from this point on, I could again reduce the samples that I got from the chicken root and continue working from it. I could also go back out of it, continue with the same workflow, or I could update on the top part and just update my channel primitives as I'm going along. And last but not least, I'm not sure if I still have time. Here's my hard goodie. And the hard goodie is a bit of a crazy example because it's a rigged rig. And it might make actually, so it's completely useless, of course, but it's a good example of how far you can actually push things. So what I'm actually internally doing, if I'm getting there ever, maybe. So that's also what I mean. It's for the curious mind. Is I'm first deforming my little hard skeleton. And I'm doing this with this abstract control. And I'm actually just manipulating a few blend shapes. That's this graph that you're seeing. Great. Now I'm grabbing that. I'm fetching the invoked information. And, well, now I can animate it. I just use the time slider and I go back and forth. And what I'm doing now is I feed that thing, my animated skeleton, into a rig build. And you can see I actually have a little FK hard skeleton now. That's great. And that's what you can see there. That's our graph. And now I can drag in the timeline. And every time I drag, that rig is being rebuilt with a complete new rest position based on my animated input skeleton. It's a bit dangerous. We don't want to introduce time dependency, but I think it's a good point of showing how interactive and responsive the whole system actually is. Because that is one of the big advantages that we can introduce, that you have a very responsive system that you can modify now in various ways, and you always have an instant feedback on the behavioral changes that you do either in the viewport or simply by debugging it through the graph directly. So with that, I'm gonna say thank you. Maybe. Yes, I am.
Questions? Might have time for one. Better be good. But we do have time for one. Yeah.
Yeah, so the folder and extension type thing to me is a pretty big paradigm shift.
Yes.
I'm just wondering if you could say any more kind of low-level details about what that stuff is.
It's nested pack primitives in the end. And we are just traversing through the nested pack primitive structure in order to fetch certain elements. And we can use a primitive intrinsic to decide if we want to use treat a pack primitive as a folder, meaning that you can actually dive inside of the geometry and analyze the given sub-elements, or if we treat it as a file. In that case, you cannot dive any further in, and you're pretty much blocked up to that part when you do a path traversal, if that makes sense.
So would you be able to do like your own extensions, or is it limited to the
you can
things?
you can do your own extensions. Nobody is stopping you from that. The current extensions that we have are partly being used by the Viewport, though. So, for example, the .char extension that we use for characters is essential for the Viewport in order to identify a folder as a character. So, and that might be also a good point to say is .char sounds like anything that has two legs and moves around. A character is defined as a rig with its inputs. So if you have a prop with a control, that's also a character. So if you use .prop, that thing will not show up in the viewport. So we do assign it for certain functionalities, but if you want to have your custom functions for generic SOP workflows, you can set this up and use it accordingly. Yeah.
Thank you.
Awesome stuff, Esther. Thank you.